In this video we're going to solve a logarithmic equation and we're going to check the solution. So you got the log of x minus 4 to base 2 plus the log of x plus 4 to base 2 is equal to 3, and we want to solve. So one of the techniques that you want to use when you're solving a log equation, try to see if you can write it as a single log by using properties of logs. So we start this way. We have the sum of two logs. So there's a property of logs that tells you when you have the sum of two logs, you can write that as the log of the product. So this can be written the log to base 2, the product of these two expressions here. X minus 4 times the other factor x plus 4. So that's the log of that product, is just to make sure that this is all included. We'll put this in brackets like this. We have this as a single log. So going back the other way, when you have a log of a product, you can write that as the log of the sum, the log of these two expressions. So the log of this product to base 2 is the same thing as this, or this side right here, and that's our equation. And then when you have the log of one expression here, using your definition of log, this expression here should be equal to this space taken to that power. So we can write this as x minus 4 times x plus 4, and that should equal to this space taken to that power. It's 2 to the third. So again, you have the log of some number x to some base equal to some logarithm. Logarithm is a number or an exponent. Definition tells you that this is the logarithmic form. To write it in exponential form, you take the, whatever this is right here, this expression, in this case x, should equal to the base b to the L power. L is the exponent. So in this case we have this product then, x minus 4 times x plus 4. So that gives you x squared minus 16. And then 2 to the third power, 3 factors of 2, this is 8. So I get x squared then is equal to, add 16 to both sides here, cancels here, and then 16 and 8 is 24. And 24 is 4 times 6. Take the square root of both sides. X then will equal to plus or minus, taking the square root of both sides, positive and a negative, x is equal to plus or minus the square root of 24, which is the square root of 4 times 6. And you can take the square root of 4, so that'll come outside the radical. You get 2 here, and then you have a 6. So we have two possible answers here. X can equal to, this goes to the square root here. X can be 2 times the square root of 6, or it can equal to minus 2 times the square root of 6. Those are two possible answers. You want to make sure that you do the steps correctly to get these prospective solutions. And then all you have to do really is make sure that if you plug these back into the equation, you don't get the log of a negative, because the log of a negative is not defined. If you're solving rational equations, those are equations with variables in the denominator, if you do everything correctly, just make sure that whatever you get doesn't give you a 0 in the denominator, because division by 0 is not defined. But see here, minus 2 square root of 6, if I try to plug this in here to check it, here it's going to give me the log of a negative, because negative 2 times square root of 6, 2 times the square root of 6 is larger than, is close to 5. And with a negative, this will come out negative. And of course in this expression over here, you have a negative 2 square root of 6 and a minus 5. That's going to be negative. So you got to reject this one. That's all you got to do to check that one. Just make sure you don't get the log of a negative. So reject this. This one is equal to 2 square root of 6. Again, this is a number close to 5. So here, you plug it in here, that'll be a positive. You plug it in here, that'll be a positive. If you did make a mistake, that's going to work. But then to check it, let's do this. We'll have log to base 2. And we'll plug it in. 2 square root of 6 minus 4. And then we plug it into the other expression. So we're actually working with the left side now. Plug it in the supposed solution here. And we want to show that we get the right side. And how we do here is just rewrite this as one expression. So I have the log, the sum of two logs should be the same as the log of the product of these two. So this sum right here should be the log to base 2 of the product of those two factors. So look at that as a minus b and a plus b. A minus b times a plus b. The difference in the sum of the same two terms is just the difference of the squares. So this would just be this quantity squared. Okay, we square the 2, that'll give us a 4. Square the radical 6, that'll give us a 6. So 4 times 6 is 24. So we get that. Okay, that's this times this. 2 times 2 is 4 again. Radical 6 times radical 6 is radical 36. Square root of 36 is 6. Then 6 times 4 is 24. And that's minus the 4 times 4 over here. And this, of course, is plus here. This was a plus on this one here. And here is minus. The other one is plus. So it's 4 squared, that's 16. We get this. And then we continue. Again, we're plugging in to the left side. And we want to show that we get the right side. That's the check that we go through. 24 minus 16 is 8. And the log of 8 to base 2. Again, it's basically asking 2 to what power will give us 8. Well, 2 to the third is 8. So the logarithm of 8 to base 2 is 3, which is what we want. So this one checks out. So that's how you solve and check the solution to a logarithmic equation. Thanks for watching. We'll see you next time.